So, moving on to the people that are actually now dealing with the not-so-new trend of AI, and we hear a couple of presentations how to get on about this, and you all will end up being inspired. Let me welcome Silvia Quarteroni. Now I managed, okay, who is doing a remarkable thing. You lead a center that actually combines forces between EPFL and ETH, and guard 25 scientists that somehow managed to collaborate in the field of AI. And I'm super, super passionate to hear about your presentation around AI, the opportunities and challenges. So please come up on stage, and everybody welcome Silvia with a very warm applause. We still have to learn about that secret, how you managed to get them to collaborate so seamlessly. Here is your clicker.
Thank you very much. Hello, everybody. So I'm the head of innovation of the Swiss Data Science Center, a collaboration between indeed EPFL and ETH Zurich, with also the Paul Scherrer Institute to add some further collaboration to the pot. Actually, I'm not the head of everything, I'm just the head of the innovation unit, and that's what I'm going to focus about in this presentation. So my objective today, after such huge motivations, is to tell you a little bit about artificial intelligence as we perceive it, and in particular, the opportunities that it offers. And to do so, I'm going to start with some introductions. Well, one of the key messages that I tend to give these days a lot is that artificial intelligence, as we hear about it today, actually refers to the very latest developments called generative AI of a technology that's been around for quite a while now. And in particular, it's been around since even earlier than 1950. 1950 is a landmark date because Alan Turing, a very famous pioneer of artificial intelligence, created the Turing test, which says essentially a machine can pass this test if it can disguise itself as a human while having a conversation with another human. So there's already a notion of, exchanging information with a machine in a natural way, which is something that's very appealing to me. I have a PhD in natural language processing from quite a while ago, actually. But of course, this is a very, philosophical almost concept. There were very few industrial applications for AI back then in the 50s. And what changed is that we moved from this idea of artificial intelligence in terms of a program that can feel and imitate a human towards very concrete applications around the 1980s when machine learning as a discipline was introduced as a way to, apply artificial intelligence and to very concrete problems. Machine learning is essentially the discipline of having machines learn from data instead of explicitly programming them with rules. So you want to, for example, distinguish an email with a good content from spam. You give examples of both categories, and you let the machine figure out which are the words that relate to spam and what is the optimal way to separate these two. You don't give the recipe precisely because usually you don't know that recipe. And this is all there is to it to machine learning. Machine learning, of course, has given great opportunities in industry and, in research, of course, for the last, 40-plus years. And even more recently, what we have observed is that a subcategory of machine learning called deep learning has emerged around the 2010s, which is very interesting because it gave us a lot of the current applications that we see today, including in ChatGPT. So deep learning, in a way, is nothing else than a subset of machine learning techniques, which allows learning from larger data sets, exploiting larger computational power through structures which are called deep neural networks. And to give you a very intuitive representation of what a deep neural network is, I just want to give you an example, which is a very classic example. I didn't come up with this example myself, to be honest. Imagine that you want to distinguish between cats and dogs. Anybody can do this. A one-year-old can probably do this very easily. However, a machine cannot really be programmed explicitly to make this distinction because there are many types of cats and many types of dogs, right? So what you can do is to feed this machine with a lot of examples of cats and dogs, and hopefully that machine is going to figure out what is the optimal way to separate these categories. For example, by looking at features like, the shape of the ears or the length of the tail or the size or what have you. And in order to learn how to best solve this problem, it's going to use a combination of learning units, which are the little dots that you see here, arranged into layers of learning functionalities in a way. And what it's going to do is it's going to start from the very beginning by watching the pixels, and progressively these units are going to rearrange themselves and give information to one another in a way that is going to allow the very last unit to output the exact label, cat or dog. And by progressively combining these different layers, actually these machines have probably learned quite a lot of stuff about textures like hair or, I don't know, eye color or something like that, shapes, basic shapes, and each time you get to another layer deeper in the deep neural network, you actually have more complexity, more abstraction capability. And this is, of course, very interesting and fascinating as a concept, but it also brings very concrete applications and applications that you can monetize. And indeed, a particular subset of this deep learning family of technologies that has emerged in the last 20, maybe 15 years or so, has seen a lot of success recently and is in everybody's heads today with applications like ChatGPT for text primarily and Midjourney primarily for images. So to go a bit further and to make some examples, I mean, what is so marvelous about these applications, right? So these applications are marvelous because they refer to a set of techniques called generative AI. They can generate content, which is something that usually we, as humans, associate to a very human capability, right? Creativity. How do they do this? They observe lots of data, and essentially they learn to generate what is the next word or the next image or the next shape or the next sound based on experience from data that they've observed. And of course, this requires a massive amount of data observation. For text generation in particular, this goes through a family of learning, let's say, techniques called large language models, such as GPT-4, which is the foundation of ChatGPT today. These essentially have been fed with the entirety of public internet, the vast amounts of books, for example, and what they have seen is essentially sequences of words. And based on these observations, they have learned not only to produce the most plausible next word, but they've also learned what they are supposed to generate when you give them instructions. So asking a machine today translate from French to Italian, for example, is something that you couldn't do 20 years ago with a learning device like a neural network. Today, the machine has learned to learn, meaning it has learned what it means to translate, what it means to summarize, what it means to, answer a question, which is something quite remarkable. So, of course, everybody, I guess, in this room has tried out ChatGPT once or twice, and maybe for silly questions like, give me inspiration for a birthday party, this is all good and well. But there are also very concrete applications in the business domains. For example, this is just an illustration of a collaboration that we have at the Swiss Data Science Center with a group called Adecco, which is one of the world leaders in HR. So their objective is to essentially match the skills described in CVs of applicants to the skills described in job ads. So their goal is to make sure that important recommendations, useful recommendations are made to applicants and that people find their jobs, which I find quite nice because it's kind of opposed to the classic notion of AI stealing our jobs and we're all going to be out of a job soon. I'm showing this picture because kind of it hints at representing information of a textual nature using the same techniques that we use with ChatGPT, but I also show it for a different purpose, which is that once my colleague was trying to recreate this picture, but without myself and the head of AI at Adecco, my colleague wanted to generate a neutral picture. So he prompted ChatGPT he prompted DALL-E to generate an image where there was some lady with a pen in her hands and a red blouse, talking to some man in a gray polo and showing him schematics. And the deep learning device, DALL-E generated this picture. And usually when I show this picture, I get giggles all the time. Actually, my colleague told me I was incapable of generating a picture where the lady would be holding the pen and she had the right number of fingers. Why is that? Because this is remarkable, right? And why is that? Because actually the quality of the generated images and let's say the nature of these images heavily depends on the nature of the data that's been used to feed these systems. And if there's not an adequate representation of ladies holding pens, lady fingers holding pens will not be generated so easily. And this applies to many other types of bias, in a way, that you will find in generated data. The very last version of DALL-E is a bit better. We have tried it out. I don't have the picture here, sadly, myself, but with the exact same prompt, we now have two people who kind of look like supermodels, but both are holding the pen. So, getting there. Anyhow, I hope I've convinced you so far that artificial intelligence as a discipline is nothing very new, but indeed, recently it's been offering quite some interesting capabilities. I just wanted to quickly tell you about one of my favorite subjects. It's my PhD subject in a way, and something that has been accompanying me for quite a while. Essentially, what I want to try and show you is what is the path that took us to ChatGPT. And it starts indeed back in the 1950s with these, the ideas of linguists that said a very simple thing: you will know a word by the company it keeps. Essentially, this intuition has been guiding the interpretation of language and text until today. It means that similar words occur in similar contexts, which means that, in a way, you can expect that you will find synonyms and words that are related in the same neighborhoods of words. And this is very connected to the way deep neural networks learn about text and learn to generate text. Of course, this was a really nice intuition, almost a philosophical one. It's called distributional semantics, but nobody really used it concretely until around the 1970s, when we introduced a way for computers to represent language in an efficient way. And this was called the vector space model. I don't want to bore you with the details, but essentially the intuition is the following. Instead of representing words as words like we write them today, you can represent words as vectors, which means as lists of, for example, zeros and ones. And how long are these vectors, these arrays of numbers? They are as long as the number of words in a vocabulary. And each word can be represented, therefore, as a vector with zeros and ones. And there's actually, for one single word, just one in the position that corresponds to that word in the vocabulary, and zeros elsewhere. And so if you want to represent a sentence, you will have ones where given word is represented and zeros elsewhere. And you can, what's so cool about this? I mean, from a human perspective, nothing. From a computer's perspective, everything, because you can then compute similarities and distances using very familiar to computers techniques, geometrical techniques like cosine similarities that we've probably all studied at school. So essentially, computing similarity, which is something that search engines have started doing in the 90s, is based on this intuition, this word representation. And everything that came after this is somehow based on this representation, this mapping of a word into a sequence of zeros and ones, or maybe even a bit more efficient sequences of real numbers, like a 0 point something and minus 1 point something else. And indeed, the big revolution that deep learning brought us was the notion of an even more effective vector representation of words called the embedding. I'm not going to give you the computer science lecture, but essentially, today we are capable of feeding a sequence of words like canine companion say, to remain in the dog allegory. We feed it into a model, we feed it into a device which is essentially a deep neural network, and we get a vector out of that. And what does this vector look like? Well, the first experiments that have been done about 10, 15 years ago with these contraptions showed us that if you take the most frequent words in collections of documents, like the Reuters news, and you plot them in a two-dimensional space, so you try to take those vectors and use them as points in a space, and you try to see who goes well with whom, you start realizing that magically, actually, these deep neural networks have learned quite a lot about the meaning of words, because essentially what they can do is they can put together things like president and chairman, which lie very closely to one another, due, likely, expected, all together. Roles fell and declined, so synonyms, but also antonyms, and opposite words and related words. So somehow, these neural networks have learned the meaning of words just by observing sequences of words and by solving the problem of what's the next word that I'm most likely going to write in that sequence. The fill the gap task, which perhaps we've all done as kids. So everything that I've been showing you until now refers to essentially developments in this technology until 2017-ish. And what came next is what brought us to ChatGPT. So ChatGPT is November last year, so it's been almost a year that we've lived with this thing. But we got here through innovation that was based on these textual representations. The key innovation, the T in ChatGPT, is actually an innovation brought along by Google. It's called the transformers, and it's essentially a technique that allows a deep neural network, so these learning devices, to focus their attention to a specific region in the text that carries the meaning that is relevant in that point in time. And as you can see from the logos of these different companies, well, there are not so many, but you have Google, you have OpenAI, you have Meta. They all progressively introduced innovative components that brought us to ChatGPT. And as you can see, the journey continues, and we have today more evolved learning approaches, and we have more evolved techniques to generate convincing and plausible language. And indeed, ChatGPT is nothing else than this transformer component with extra layers, and these extra layers are essentially two things. One layer is based on a particular machine learning technique called the reinforcement learning, and it basically ensures that what you as the human ask will be met with a helpful response. Not going to go into the details of this, of course. And the further layer is the safety guard, which is that despite the machine willing to be helpful with you, if you ask it to ways to fabricate a bomb, it's going to tell you, I'm sorry, this is not what you should do. Or if you want to fire an employee because of the way they look, and you are looking for advice from ChatGPT, it will probably tell you that this is not a good thing to do. So that's the safety layer that is applied over this whole thing. Just a few details. I don't know how bad I'm doing with time. How long do I have? 0 minutes? Okay. Then I'm just going to finalize by saying that GPT and all these innovations are extremely proficient at addressing a very specific human tasks. They sometimes do better than the human, but they have important limitations too. And one of these limitations is the generation of plausible but not real content, which we need to somehow address. They also lack a lot of common sense. They generate plausible text, but they cannot solve logical problems, math problems that a kid could solve. So we still have a lot of ground to cover there. We have many other business limitations. I think Hugh will talk about regulating AI and what it means for companies, so I won't go into the details of that. I just want to say that, just to recap, AI has been there for quite a few years now. We have great opportunities and great also sizable market investments in very diverse domains thanks to these recent innovations, and it would be a pity to not to exploit them. Thank you very much.